Yellow. Today we will be furthering our discussion on probability and showing you a few models or pictures to help you solve more complex problems. The first is a Venn diagram, which hopefully you've all been exposed to before in some of your other classes. It's used to compare and contrast certain things. You have this overlap in the middle that's what the two have in common. It's similar to that in probability, but a little bit different because we're dealing with numbers instead of people. And the other one will be a small table that you will use that's basically this very similar but a little bit different way of looking at the problem, but it will still give you the same answers. Okay, so we've got a Venn diagram here. The whole diagram represents the sample space or all possibilities. For generic versions, we use A and B, and the total area is 1. Now we've got this overlap here that we're going to call A and B. That's the intersection of A and B. Now, in less mathematical terms, that just means both. Okay, on this left side here, we have A and not B. Remember that little C means not. Again, in less mathematical terms, that means just A. On the right side, we've got not A and B. In other words, just B. And in the bottom, we've got neither. Okay, it's still in the square or the rectangle, but it's not inside either one of the circles, so it's not A and not B. And remember that little not, the little C means not B. Just a little quick review. Okay, so in the past, we talked about an addition rule where you could just add the two probabilities if you wanted or. So in this example, you have A or B, and we can just add A plus B. Now that works out very nicely when the two events are mutually exclusive or disjoint. That's a topic we've been talking about. Okay, and you can see it pretty easily in this example that the two are disjoint because there is no overlap. There's nothing in common. They both can't occur simultaneously. So it's very easy to just add A plus B to get the probability of A or B. Okay, either one of those circles basically. Now, if we look at the same example, but we shift this circle over a bit, now these two have an overlap. Okay, so that becomes a little more challenging, not too bad. Let's use a crayon here to help us color. So if I take the probability of A plus the probability of B and add those two numbers together, I'm going to have a problem because there's an overlap there. That little circle in the, or that little section in the middle was accounted for twice, once in the blue part A and once in the blue part B. So this intersection here, A and B, is actually added twice. So in order for this formula to work, I've got to subtract the probability of A and B. Okay, now that's our new addition formula, and that is on your reference sheet. So that's the one we'll be using from this point forward. It still works with this one, just the overlap is basically 0. So that's why that formula can still work for disjoint events. Okay, so here's our first example. A survey of college students found that 56% live in a campus residence hall or dorm, and 62% participate in a campus meal program, and 42% do both. Okay, so I'm going to list my probabilities using probability notation. So let's call this residence hall, and we'll say that that's 0.56. And campus meal program, probability of that is 0.62. And 42 do both. So the probability of a meal plan and residence hall is 0.42. Now, a quick check that you can see that the addition rule, the normal addition rule is not going to work, is that these two things already are over 1. So obviously there's some sort of overlap there. Now, according to my formula, let's say that I want to find the probability of a meal plan or a residence hall. Well, according to my formula, that's the probability of a meal plan plus the probability of a residence hall minus the probability of both. Okay, so if I just plug in these numbers by my formula, 62 had a meal plan, plus 0.56 were in a residence hall, minus the overlap, and I will get minus 0.42, 0.76. Okay, now below I'm going to show you how to use a Venn diagram to get more or less that same answer and answer some other questions. So first thing I want to do is draw my Venn diagram. Okay, make the circles big enough so that you can fit the numbers in there, and you may need to make them more like ovals. That may be beneficial. Okay, so I've got a meal plan and I've got a residence hall. So we said that the meal plan was 0.62 and the residence hall was 0.56. Now, I don't put those numbers in the circle yet because they're not just meal plans or just residence halls. Okay, they don't go in the circle, and that's a common error that students make. I can put this overlap in here. That's the and. So, to get the just meal plan, all I'm going to do is take 0.62 minus 0.42, which is going to give me 0.2. Okay, so again, both those sections there, 0.2 and 0.42, will add up to the total here. Over here, this whole circle is 0.56, so if this is 0.42, this is the difference. So I'm going to take the total, 0.56 minus 0.42, and get 0.14. Now, what's left over, what goes in the bottom right corner, is basically 1 minus 0.2 plus 0.42 plus 0.14. So if I take those three things added together, because I know that they all add up to 1, okay, I get the 0.76, not a coincidence. So this is 1 minus 0.76, which gives me 0.24 left over. Now, if we go back up to the original answer that we got, which was 0.76 for meal plan or residence hall, it's, again, not a coincidence because these three areas here, boom, 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 are part of the circles and therefore part of either M or R, and this is neither. So really the sum of these three would give me the same answer. Okay, randomly selected student lives off campus and doesn't have a meal plan. So in probability notation, that's no residence hall and no meal plan. Okay, so that's basically neither, which according to my graph is this area right here. Okay, it's not in M or R. Okay, it's neither. So we'll call that 0.24. That's the answer to the first one. Okay. Randomly selected student lives in a residence hall, okay, but doesn't have a meal plan. So if we look at this, lives in the residence hall, okay, but doesn't have a meal plan. So it's everything but that overlap. It's this piece right here, okay, which is going to give me, according to probability notation, it's residence hall and no meal plan. So that is going to be 0.14. Okay, so the Venn diagram makes things a little bit easier to answer questions once I've got all the divisions. Okay, second problem. Police report that 78% of drivers stopped on suspicion of drunk driving are given a breath test, 36% are given a blood test, and 22% are given both tests. Create a Venn diagram and answer the following problems. Okay, so we start off with our Venn diagram. Okay, and then we label. We'll call, because they both start with B, I don't want to use a B, so I'm going to use R for breath and L for blood. So basically, the probability of a breath test is 0.78. The probability of a blood test is 0.36. And the probability of a breath test and blood test is 0.22. Okay, and as you can start to see, the symbols get a little bit confusing, which is why I really like the Venn diagram. So we've got total R is 0.78, breath test. We've got total L for blood test is 0.36, and the overlap is 0.22. Okay, so I simply subtract 0.78 minus 0.22 to get 0.56 over here. Okay, again, if this whole circle is 0.78 and this part's 0.72, I subtract those two numbers to get the 0.56. I'm going to subtract the 0.22 from 0.36 and get 0.14. I'm going to add those up and subtract from 1. 1 minus 0.56 plus 0.22 plus 0.14, and that will give me the neither. Okay. Whoops. Okay, so this is 1 minus 0.92, which is going to give me 0.08 for the neither. And now that I have the Venn diagram, it makes it a little bit easier to answer these questions. So, what's the probability that a person's given a test? So basically, that's, again, the probability of R or L. So, probability of R plus the probability of L minus the probability of both. So, 0.78 plus 0.36 minus 0.22, and that's going to give me 0.92, which again is not a coincidence that that's the same number we got down here at the bottom. Okay, that's this, or this, or this. A blood test or breath test, but not both. Now that's kind of tough to write out in the notation, so I'm just going to kind of show you what that one looks like. So I grab my highlighter. That's just breath or just blood, but not both. So it's basically 0.56 plus 0.14, which is 0.70. And the last is neither test. And again, I don't have to do a whole lot of math for that because I've already done the Venn diagram. That's not a breath and not a blood, and it's just 0.08. That's this little section down here. Okay? Now, I'm going to quickly show you how to do the first problem using a table. So, if we go back to the first problem, we talked about the residence hall and meal programs. So, a table basically looks like this. I'm using R's for residence and M for meal plan. So here's what my table looks like. I'm either going to have a residence plan, or live in a residence rather, or not live in a residence. I have to fall into one of those two categories. I'm either going to have a meal plan, or I don't have a meal plan. I have to fall into one of those two categories. Now, if I kind of finish this off, I get a little table. We write totals over here and total over here. And of course, the ultimate total is always going to be 1. Now, it's a little bit easier with the table to see the divisions as opposed to a Venn diagram. So, we said that 42% did both, so that's M and R. That's the, you can kind of see the intersection of these two things. The total M, so again, that's the total that have a meal plan, is 0.62, and the total that live in a residence hall is 0.56. So I put that down on the bottom for the total R. Well, basically, I know that these two things have to add up to 1, so this is just 1 minus 0.62, which gives me 0.38, and 1 minus 0.56 over here gives me 0.44. Now, what I end up with is kind of a little puzzle here. I just subtract across, so take 0.62, all right, minus 0.42, and you get 0.2. I take 0.56 minus 0.42, and I get 0.14, and subtract again here, and I get 0.24. And they all have to kind of fit in. And now it's very easy to identify things like, okay, the probability of M and not R, meal plan, not residence. Well, I can just overlap and M, not R, and get 0.2.